This is Signal and System Practice Homework 8.2, Question 1. By direct integration, find the Laplace transforms and region of convergence of the following equations. First, let's see this equation. It's easier way to say this is just to use the plot of these equations. For the ut, it's directly this part, 0, 0, and for the ut minus 1, which is this part. And since the ut minus 1, so eventually they will left this part. So we can start doing the Laplace transform, which the definition is the integral from the negative infinite to infinite, and ut minus 1 times e2 minus st dt. And we can see, because it's a green part, so actually we can simplify this 0 to 1 integral of e2 minus st dt. And then we can see no matter how the value s is, this integral is always convergence. So actually we can just simply get the integral of this equation, which is 1 to minus s e minus 1 to minus s. And another part is s can be any value. It's just the infinite. Is if only if s larger than the negative infinite, which means any value, this Laplace transform is convergence. And for the next question is still we use the definition of the Laplace transform, which is fs equals to integral from negative infinite to infinite t times e2 minus t ut times e2 minus st dt. And because they're ut, so it's integral from 0 to infinite t times e2 minus t times e2 minus st dt. And we can do the integral of this equation, which is from infinite t 1 plus t 1 plus s t dt. And we use the Hopital's rule. We can get the integral is minus 0 infinite t 1 plus s d e2 1 plus st. And this equals to minus 1 plus s t times e2 minus 1 plus st, integral 0 to infinite, and minus the integral from 0 to infinite e2 minus 1 plus st dt. And then we can get more simplify, which is minus 1 over 1 plus s. The first one is 0 minus 0 and plus 1 over 1 plus s times e to 1 plus s t 0 to infinite. And we can see to make here is convergence, we need to make sure first we get if it's convergence, we can get 1 over the square of 1 plus s, and to make sure this is convergence, we need 1 plus s is larger than 0, the real part at least. So which means the real part of 1 plus s larger than 0, so we can get the range of s, or the real part of s, is larger than minus 1 to make the convergence. And for the question C, first we start with the definition of the Laplace transform, which is integral from negative infinite to infinite t cosine omega 0 t u t times e to minus st dt. And since there is ut, we can write 0 from 0 to infinite t cosine omega 0 t dt. Then we use the Euler equation. We can convert this to the exponential e to j omega 0 t plus e to minus j omega 0 t 1 over 2. They equal to each other, so we can write 1 over 2 0 to infinite t e to j omega 0 t plus e to minus j omega 0 t. Oh, sorry, here is I forgot to write there is times e to minus sin t dt, right? So here is e to s minus st dt. And we integral separately to this equation, so we can get 1 over 2 integral from 0 to infinite t e to j omega 0 minus st dt plus 1 over 2 infinite from 0 to infinite t e to minus j omega 0 plus s t dt. And similarly, from the last question, we use the hospital law, so we can eventually get after the calculation, eventually we can get minus e to j omega 0 minus st over 2 j omega 0 minus s squared 0 to infinite minus e to minus j omega 0 plus st over 2 j omega 0 plus s squared and 0 to infinite. And we can get, for more simplification, we can get the final answer is s squared minus omega 0 squared, and the denominator is s squared minus omega 0 squared. For here, to make this integrable is a convergence, so we need to make sure reg omega 0 minus s smaller than 0. And for this part, we need to make sure at the same time we need to make sure the real part of the g omega 0 plus s is larger than 0. So combine these two together, actually it's just for this is like minus s smaller than 0, so, and this is s larger than 0, so combine it actually is real part of s is larger than 0, right? So this is the final one. S, the real part of s is larger than 0, it's a convergent. And for the question D, we still start with the same process, which means the definition of the Laplace transform, integral from negative infinite to infinite, e to 2t minus 2e2 minus t ut times e2 minus st dt. And since there is ut, we can write 0 to infinite e2 t minus 2e2 minus t e2 minus st dt. And we just divide this into two parts, which is 0 to infinite e2 2 minus st dt minus 0 to infinite 2e2 minus 1 plus t dt. And okay, so this is just simply integration, so 1 over 2 minus s times e2 2 minus st, and the integral from 0 to infinite and plus 2 over 1 plus s e2 minus 1 plus st from 0 to infinite. And first, let's just because to make sure it's convergence, we can get the final integration is 1 and minus 2 over s plus 1. To make this two is interconvergence or integrable, so which means here is convergent. So that means the real part of 2 minus s should be smaller than 0 at the same time, and 1 plus s, real part of 1 plus s is larger than 0. For this one, we can get the real part of s is larger than 2. And for this part is the real part of s is larger than minus 1. So combine this together, eventually the real part of s should be larger than 2. So this is the final question. Thank you.